So this little video is designed to help you do well on the first test, by which I mean to pass it on your first attempt. Many people don't, and many people take the test over and over again and become increasingly frustrated. The reason for this is simply that they haven't really taken me seriously with respect to the need to do all of the homework, do all of the practice tests, etc. But that's really perfectly understandable. You just don't know how serious a matter this is until you've sort of tested the system. But if you do decide to test the system by taking a test prior to developing a full understanding of the material, then you might find yourself back here figuring out how to succeed. So the key to doing well on this first test, hopefully you've looked at the practice tests, is to make sure that you have an unerring ability to determine A, whether something is a Woof, and B, if it is, what the main operator of the formula is. Now, it's also very important to be able to translate English formulas into propositional logic, into Wofs in propositional logic. And it's also very important to be able to handle unusual operators like unless and only if, and be sure that you've engaged the videos where I discuss this. But you can miss one of those and still pass the test. You can't miss any of the Woof formation problems and or the Woof detection problems, excuse me, and pass the test. So you have to have, like I said, an unerring ability to do this. And the way to understand how to approach the determination of whether a formula is a Woof is to make sure you have a complete grasp of the formation rules for propositional logic, which you see written here, and specifically how to apply them to the determination of whether something is a Woof. So this is actually, as I say on the top of the page, it amounts to a kind of proof. So there's no guesswork here at all. You can actually apply the formation rules, and as a result of directly applying the formation rules, determine absolutely whether something is a Woof or not, and also determine what the main operator of that Woof is. So let's briefly review these formation rules. So rule 1 says that any capital letter is a Woof. So that would be any capital, and remember these are always capital letters, never use lowercase letters or you'll get a translation wrong. So capital P, capital Q, capital R, capital S, capital T are what we normally use when we're not translating anything in particular. Rule 2 says if phi is a Woof, then not phi is a Woof. Now the reason these are written in Greek letters, although I ultimately abandoned this practice, is to make it clear that we're talking about any Woof whatsoever. So this, for example, tells you that if A or B is a Woof, which it is, then not A or B is also a Woof. Okay? So anything that has already been determined to be a Woof, you simply add a negation, and that is also a Woof. Now, rule 3 tells us that if two things are Woofs, then you can put them together with the ampersand, the wedge, the arrow, or the double arrow with brackets and make them Woofs, make that a Woof too. So for example, if you know that P is a Woof and you know that Q is a Woof, which they both are, then you can put P and Q together with, say, an OR with brackets, and that's a Woof, right? And also, if you know that P or Q is a Woof, and you know that, for example, R, if and only if S, and not T is a Woof, which it is. So if you know both of these are Wofs, then you can put these together with brackets, like so. Okay? So those are the three Wofs that actually involve us in forming, those are the three rules that actually involve us in forming Wofs. Rule 4 is very important. It says nothing is a Wof that cannot be constructed using rules 1 through 3. So what Rule 4 is telling you is that you can use rules 1 and 3 to determine whether something is a Wof. And what I'm telling you is that you should always do this, because if you don't, there's always going to be at least one on the test that convinces you that it's a Wof when it's not. So let's just finish up by actually doing some of these so that you can feel what this process is actually like. So I'm going to try to determine whether not parentheses, not P parentheses is a Wof. Well, how am I going to do that? Well, I am going to try to build it, right? So how will I do this? Well, I know by rule 1 that P is a Wof, right? Well, now what can I do? Well, rule 2 tells me that not P is a Wof, because if something is a Wof, then not that something is a Wof. But now, in order to continue building this formula, I need to add parentheses. So what rule will allow me to add parentheses here? The answer is no rule allows you to add parentheses here, right? Just look at rule 1, look at rule 2, look at rule 3. Rule 3 allows you to add parentheses, but only with and, or, if then, and if and only if, right? Only when you are, for the binary operator, where you are putting together two distinct Wofs. So this, as a result, is not a Wof, because it cannot be built with the formation rules, and you would simply write on the test, not a Wof. I don't require you to explain this. Okay, now let's look at another one. Is this a Wof? It would be a good idea for you to stop the video now and figure this out for yourself. So how will I proceed? Well, start at the atomic level. P is a Wof. Q is a Wof. Fine. Okay, now what else can I do to try to build this formula? Well, I can't put parentheses here because I've got this not that I have to establish first. But if P is a Wof by rule 2, not P is a Wof. And now if not P is a Wof and Q is a Wof, then, then this is a Wof. And remember, I have to add the parentheses, right? And if this is a Wof, then by rule 2, this is a Wof. And that's exactly the same formula, right? So now, if you identify that something is a Wof, you're also required to tell me what the main operator is. And the main operator is always the last operator that you added. So in this case, we know that this is the main operator, the negation, because it was the last one we added to the formula in building the Wof. It could not have been the or, because we had to put the or in first before we added the negation. So although I emphasize different ways of thinking about the main operator, namely that it's the one with widest scope, that has scope over the entire formula, in this procedural sense, the main operator is the operator that you add last in building a real Wof. Okay, so let's look at a couple more before closing this video and getting you on your way to success in the first test. So here's some longer ones. This is of no interest at all to you that they're longer because you're still just applying these rules in a very straightforward way. So what are you going to do? Well, let's say write down the atomics first. So P, Q, R, S, and T. Just write them all down because you know those are all Wofs, right? Okay, so then look closely at the formula and see what else you can do to make, using the rules explicitly, right, to make this formula resemble this one. Well, what I see here is that if P and Q are Wofs, then P or Q with parentheses is a Wof, right? And I see exactly the same relationship with R or S. All right, that's good. Now what else can I do? Well, if R or S is a Wof and T is a Wof, then I know that if R or S, then T with parentheses is a Wof, and that's still all looking very good. And then I can just keep going, right? Because if I know R or S, then T is a Wof, then I know by rule 2 that not that is a Wof. And then since I know this is a Wof, then by rule 2 again, I know that not that is a Wof again. So we're fine. This is a Wof as well. And can we keep going? Well, what can we do? Well, look, it's not the negation, right? Because if you added a negation here, these two you'd have one parentheses, we need two. So, but we can say, well, since this P or Q is a Wof, and not R, S, and T is a Wof, then we can put these together with the ampersand, and that becomes a Wof, right? And again, it still looks right. It's still the same formula we're trying to build, except we have one last thing to do to make it the exact formula: negation by rule 2, and there you go, right? That is a Wof. It's exactly the same formula. And the negation has to be the main operator. Why? Because it's the one we added last. All right, let's look at one last one. So is this a Wof? Let's try. Let's see what happens when we try to build it. So let's just write all these down. S, T, M, P, G. Okay, well, P or G by rule 3 definitely is a Wof, with parentheses, of course. Always have to add the parentheses when you're building a true Wof. T if and only if M. Yep, good. T if and only if M. That's a Wof by rule 3. Always know which rule you're using. And since T if and only if M is a Wof, then not T if and only if M is a Wof. Excellent. Okay, now what else can I do here? I'm starting to sense a problem, because if I want to put that and in here, right, I have to put parentheses here and parentheses here. And notice that is not that formula. And that's the only way I can get the and in. So this is not a Wof, right? It's not a Wof because we cannot construct it using the formation rules. Okay? So that's how it works. If you are willing to be patient, learn the formation rules, apply them in exactly this manner, the probability of you doing well on the first test the first time is much, much increased from not doing this. Okay.